So calculating the p-value, as I mentioned before, there are two main methods. Though in this case, we want to use the table when possible and only the approximation when interpolation is impossible. Then the first method is that p-value calculated through interpolation of values found in a table. We'll go through the interpolation process on the next slide, but it's pretty easy. It's just linear interpolation, very similar to what we did in Shapiro-Wilk. The second is using an approximation equation. Now this method is only accurate to 2 decimal places, so 0.0x, so that hundredths place there, which is why we want to use the p-value table as much as possible, because we can get the actual values or a better approximation than using this approximation. So let's say that we have an n of 30 and a ks of 0.104. We find our n row, and then our lowest value here is 0.1315, which means that we can't do any interpolation because it is so low that it's greater than 0.2. Now in some scenarios, your organization might just care that it's greater than 0.2, but you might want to know how much greater. Are you at like a p-value of 0.8? Or are you at a p-value of 0.201? You know, that can be helpful to know because as we remember from the Anderson-Darling, the p-value really is a metric of how closely it follows the normal distribution. And a higher p-value means it follows it much more closely. So it can be good information to know. So because we can't use interpolation, we're going to have to use the approximation algorithm. And the approximation algorithm is pretty simple. P equals the sum of ci times ai, where I goes from 0 to 10, because the 0 cancels out. We have a c0 here all the way up to c10, and then a to the 10th. Now a is something we're going to have to calculate because it's really not that bad. It's pretty simple. You have these b1, b0, and b2 constants that we have up here, very long decimals, just like the c constants. And then ks is our KS test statistic, and n is our sample size. So again, none of this is really complicated. It can just be a pain to type all of these numbers into Excel. If we were to plug it all in with that n and that ks value, we get an a of 2.90777 and a p-value of 0.546, which is greater than 0.2. So that is awesome. The thing to remember is that we are only accurate to this. So due to rounding, it could be 0.55, 0.54. We aren't super sure. But again, this is a high enough p-value that we are going to be okay.